Today we are going to take our knowledge of probability from 11.2 and apply it to dependent and independent events. Starting with independent. Independent events are two events in which the outcome of one event does not affect the probability of the other. So for example, flipping a coin and then flipping a coin a second time. Those two events are independent of each other. So if we have that, that's like an intersection. And the probability of A and B happening would be taking those two probabilities and multiplying them. And so one thing you want to remember is that replacement is going to be very important, because if there's with replacement, then those events are going to be independent, and because your chances don't change with each time. However, we also have dependent events. Dependents are where the outcome of one event affects the probability of the other occurrence. So if you have 2 lemons and a lime in a bag and you choose 2 pieces, you are going to have an increased chance of getting a lime if a lemon is already chosen, but you have starting off a better chance of a lemon. So then it would be the probability of A then B being, taking the probability of A, and then the probability of getting B after you've selected A. So that means when you have without replacement. In other words, it's dependent because our chances will change. So if we take a look at finding probabilities of independent events, we have the probability of flipping heads, tails when tossing a coin 3 times. So this is independent because when I toss this coin each time, the previous outcome has no effect. So to me, that means that we're going to take the probability of flipping a heads times the probability of flipping a heads times the probability of flipping a tails, which in the case of a coin is going to be 1/2 times 1/2 times 1/2, which is going to be a probability of 1/8. Now, at the same time, probability of rolling a 1 on one cube and a 6 on the other cube and rolling 2 number cubes. So rolling a 1, so that's going to be a probability of rolling a 1 times the probability of rolling a 6. Which is going to be 1 out of 6, because there's 6 possible outcomes, times 1 out of 6, which would be 1 out of 36. Because if you think about it, it would be a permutation if you thought about it, because if we think about having 2 cubes of 2 different colors, a 1 on cube 1 and a 6 on cube 2 is very different from the opposite effect. Now, taking a look now at dependent events. So we have Sally, she has a bag of marbles. Inside the bag are 2 blue and 3 red. And you draw a marble and then a second marble without replacing the first. That's the key there, because once you take one out, then you have less of a chance or more of a chance depending on the color selected. So if we look here, this is saying probability of drawing 2 blue marbles. That's the probability of drawing a blue times the probability of drawing a blue after a blue has already been chosen. So in our bag, we have 2 blue out of 5 marbles. So then if I now draw a blue one out and I don't put it back, I now have 4 marbles and only 1 of which is blue, because I've already removed it. So if we think about our bag of marbles, and we've got our 2 blue and our 3 red, and I take out a blue marble. Now I'm down to 1 out of 4. So then I multiply this, 2 times 1 is 2, 5 times 4 is 20. I simplify that to 1/10. So there's a 1 in 10 chance of drawing 2 blue marbles. Taking a look at our next example, we have 2 red, 5 green, and 8 yellow gummy worms in a jar. So if it helps you to draw a picture, here's my jar, and I've got 2 red, I've got 5 green, and I've got 8 yellow. Beautiful drawing, isn't it? So Melanie's going to randomly select 2 gummy worms from the jar without replacing the first. She's going to eat them. So we want the probability of a green times the probability of choosing a green after she's already chosen and eaten the first green. So 2 plus 5 plus 8 is equal to 15 gummy worms that she has initially to choose from. And we have 5 green, and then if she chooses a green, we're now down to 4 green out of 14 total gummy worms. I'd prefer to simplify this ahead of time because it'll make my life easier. 5 and 15 are both divisible by 5, that gives me 1/3. 4 and 14 are both divisible by 2, giving me 2/7. I multiply through and I get 2 over 21. It's not simplifiable, so my probability is a 2 in 21 chance of selecting 2 green gummy worms. And give these U-Try problems a shot, these 2, and enter your answers in the Ed puzzle and bring your questions with you to class tomorrow.